Hi everybody and welcome back to my backyard once again. Today I'm gonna show you how to add a GPS on an FPV drone, and not only that, but how to install Betaflight 4.6 and activate position hold. You press a switch and the drone stays still in the air, maintaining its altitude and its position, just like a DJI one. You can remove your goggles, talk to someone, and the drone sits still. The drone I will use today is the GEPRC Vapor D5. It's my favorite 5-inch with the 4 Pro system so far because it's flying better, it's better quality, and it's way cheaper than the competition. So if you're looking for a 5-inch, I really recommend this one. When you buy this drone, you have the option of getting a GPS pre-installed from the factory, and that's what I suggest getting. My version doesn't come with it, so since I had to install a GPS anyways because I like this drone so much, why not let you come along and show you how it's done? The first thing to consider when installing a GPS module is what model to buy, because they come in 1,000 different brands and varieties. My suggestion is getting anything with the latest M10 chip inside. As for 2025, is the fastest chip available. It's not very expensive as well, so really is a no-brainer. It picks up satellites in seconds and it's super fast, precise, and it's gonna really make a difference for position hold where you want the most satellites possible. For example, both of these GPSs have a M10 chip inside. They are gonna work similarly. Of course, the bigger one is gonna be a little bit faster, but the main difference is usually the slightly bigger ones. They also come in an intermediate size usually. They have a magnetometer inside, basically a compass, and that's gonna be incredibly useful for the position hold. It's gonna make it much more precise. And you can tell the difference because this has 4 wires, this has 6. So my suggestion for the time coming is, unless you are really limited on weight, get a GPS that's M10 and also has a magnetometer inside. And now that you know what model to get, let's talk about where to put it on a drone for maximum performance. Usually you want it the furthest from the VTX antennas because they create a ton of interference and it's gonna degrade the signal coming into it. With M10 module, they are powerful enough that it doesn't matter as much as before, but usually if you put it in the front, it's the best. Sometimes you have to put a GoPro mount here, so making it fit, it can be difficult. You can put it on the arm if you have space, maybe on bigger drones, it makes sense. But of course, if the propeller strikes it, your GPS is gonna go bye-bye. Putting it here is kind of suboptimal, but it can be fine. Here is not the best because it's literally touching the antennas. And actually GEPRC designated this spot at the back for the GPS to hang from. So I just designed a mount in TPU that screws in like this, and it holds the GPS at an angle. So when I fly cruising, I have the GPS pointing up in the sky. If you have this kind of GPS, I'm gonna leave the link to download the mount in the description. And now let's open the drone and wire everything up. To connect the GPS to this board, we need to actually flip it because the pads are on the bottom, so I actually need to remove all of these side paneling. Okay, it's not too difficult actually. And now we have access to the pads on the bottom. So starting easy, if you want to connect a GPS that only has 4 wires, you need to locate a free UART on your board. A UART is like a USB connection, basically. You need 2 pads, a R pad and a T pad, and they correspond to the same number in the port selection in Betaflight. So this is port 3, this is port 4. And since you have 4 wires, not only you need data transfer, but also voltage in and ground. So, for example, you have ground, 5 volt, R3 and T3. You connect them to red wire, which is voltage in, goes to 5 volts. The black one goes to ground, it's ground. Then you have R, which is the yellow, goes to T. They always go inverted because this receives what this transmits. It's really easy. This transmits information that's received by the receive pin on your GPS. So yellow goes on T3 and the white goes on R3 basically. And this GPS can be connected to wherever you want. If your GPS comes with a compass, you will have 2 extra connections to make for a total of 6 wires. You have the previous UART, so you have RX and TX voltage and ground, just like before. So we will connect them to T4, R4, 5 volt and ground. But also you have L and A that go here. SDA goes to A and SCL goes to L. They are the connection for the magnetometer. So make sure your board has these 2 extra connections if you want to use the compass on your GPS. So I'm just gonna solder them and we'll be ready. And now that it's soldered, we can turn the board around again and reassemble everything. And now we are ready for the setup. Connect your drone to Betaflight, and if you don't see the light of the GPS turning on, assuming you have wired up correctly, it means that the flight controller doesn't pass the USB voltage to it. So you need to connect a battery. The drone turns on, and you can see the GPS now has the light on. In the top section of Betaflight, you can see that the magnetometer icon and the GPS one are not active. This means, of course, we need to activate them. Go into the ports tab. Remember which UART you soldered your GPS to. In my case, is UART 4. So UART 4, it's empty. Nice. Let's go and activate GPS in sensor input. As the baud rate is the communication rate, you can set it to auto. I read the manual of my GPS and is the maximum. So save and reboot. Now hopefully, no, we don't have the GPS active yet. Oh, okay, now it's reading, sorry, it's reading now. You need to also select the magnetometer option for it to work. If your magnetometer option doesn't remain turned on, it means probably you need to reflash the firmware with the magnetometer option selected when you flash the firmware. I'm gonna show you later when I update it to 4.6 how to select those options. Even if you don't have the GPS tab right here, remember you need to reflash the firmware with the GPS selected at flash. Now we have the GPS option. So first one, use GPS. The second is the GPS protocol. Depending on your GPS, you have your info sheet. In my case, it's U-blocks. Most are gonna be U-blocks, M10s. Then you can leave selected auto config because it's easiest. Use Galileo. Galileo are Italian satellites and you have more satellites to work with, which is a good thing, so use it. Set home point once, I will keep it on because it means when you get the first satellite fix, wherever the drone is the home point. It doesn't reset if you land somewhere else. It only resets if you unplug and replug the battery in, then it gets a new home point. If you don't select it, maybe you land somewhere else, that becomes the new home point. So it could be a little bit, maybe if you are on a moving object like a boat, you want your home point to reset every time you land. But if you land, just power cycle the drone and you are set. And now let's set up the GPS rescue function. So if you lose signal on your drone or if you press a button, the drone turns, goes high and comes back and lands. Very, very useful and it could save your drone. That's why I want to put a GPS on here. Go into failsafe and finally you can change the failsafe from dropping the drone when you lose signal to GPS rescue. And actually most of the settings here are gonna be fine because altitude mode, maximum altitude. If you go 100 meter high in your fly, the drone is gonna go 100 meter and come back. This avoids it crashing into obstacles. It has no way of knowing if there are obstacles in the middle. So maximum altitude usually is fine. If you go very, very high, the drone is gonna come back very, very high and lose a lot of battery. So always keep in mind. Otherwise, you can select fixed altitude, put 60 meters, and usually at 60 meters, it's fine. It depends on what you wanna do. Usually I don't fly that high, so it's fine. Initial climb means how many meters it goes straight up before starting the GPS rescue and going sideways and climbing to the maximum altitude in this case. 10 meters is fine. You went over a house, goes and then it comes back. These other settings, ascent rate, return ground speed, the maximum pitch angle usually are fine. If it's a big drone, maybe you can do 8 meters per second. It's gonna come back a little bit faster, maybe even a little bit faster than that, but usually it's fine. descent distance 20 meters. It means that when the drone is 20 meters from the home point, it's gonna start to descend gradually. And when the gyroscope feels that it hits something, it shuts down the motor. Throttle minimum and maximum, you can leave it at that. Throttle hover is a very important value, as the note says right here. You should set it correctly, otherwise the drone is gonna either descend or ascend very high. You need to go out, fly, hover, check out at what percentage your throttle is when you're hovering, then go into the receiver tab and cross-reference. It was 30%, put it back at 30% and check the number here on the slider. It's gonna be around 25-30%, so probably the number here is fine. Minimum distance is the minimum distance you can activate GPS rescue from your home point. I will leave it at 15 because it's very fine. If you put it higher and you are maybe testing the rescue mode and you are not done more than, I don't know, 15 meters for example, the drone is gonna drop, so be careful with that. Minimum satellites you can leave it at 8 because at least you have a precise home point when taking off. And allow arming without fix, I will leave it on. You just need to remember that wait for the drone to have 8 satellites and the home point set, and then you can fly, because otherwise the drone is not gonna arm until you have all the satellites. Maybe for this kind of 5-inch it's fine, but for smaller drones, maybe you wanna fly indoors, you don't need to get the GPS fix and the drone is not gonna arm until you do. So I will leave it turned on, but beware. And congrats, your drone GPS is now correctly set up and ready for GPS rescue. So if you lose your drone signal, it's gonna come back at you and you're not gonna lose it. But now let's do something more interesting, which is position hold. Press a button and the drone, just like a Mavic, waits for your command, staying still in the sky. And you can also pilot it just like a Mavic. It's super cool. At the moment I'm filming this video, is still development version of Betaflight 4.6. Soon it's gonna come out. So if it's come out, just ignore something I'm doing right here. To do that, we need to, first of all, save a preset of our drone so all the settings are stored correctly. And to do that, go into presets, save backup here in the top, and just save it in a folder you recognize. I have a drone folder on my computer, so I know that. Perfect. And our configuration is saved, so when we update it, we can just load the previous configuration and everything will go very smoothly. And now let's go update the firmware. At the moment I'm recording this video, to select Betaflight 4.6, you need to go into Development, Detect the Board, 4.6, Dev. Be careful, this version could have bugs because it's not still alpha, of course. But it's fine, most probably. Radio protocol, it depends what you're using. I'm using the DJI 04 with the DJI radio and I need to select S-Bus for it to work. If you use ExpressLRS or Crossfire, select CRSF. OSD protocol digital because I'm using the DJI 04 again. Other options, here, wherever you are installing 4.6 or 451, always select GPS magnetometers, and for this 4.6 we are gonna select position hold and also altitude hold. Now load firmware online. It's gonna take a little bit because it's, I don't know, the servers for these development versions are a little bit slow, so I'm just gonna wait. Nice, now it's loaded, let's flash the firmware. It's gonna tell you to create a backup at this point. You can create a backup even now, but we created it before at the presets tab. It's the same exact thing. I'm just gonna ignore the risk because I don't wanna duplicate. Here it warns you that there could be bugs, of course. One day is gonna be a normal release and everybody will be using 4.6. It's gonna come soon, I hope. Perfect, the drone has been updated. Now close this warning, let's go straight into presets and load the backup we did before. There are gonna be some errors because we just updated versions, maybe it's not gonna be, yeah. There are some minimum errors, but probably nothing to worry about, I hope. I don't only suggest you to create a backup, but also go into PID tuning and take a couple of screenshots of your settings and also your filtered settings, because they can be messed up sometimes when you change firmware versions. Now all you need to do to activate position hold is go into the modes tab, and as you can see there is halt hold, add range, and I'm gonna put it on aux 2 when it's in the center, so I just flip a switch and it holds altitude. And still you can fly, but it's holding altitude. If you want the drone to completely lock in place, you also need on the same switch to select altitude, position hold. Position hold makes your drone stay still, but if you don't select the altitude hold, it can still apply throttle. So if you apply both of them at the same time, the drone stays locked in, it enters some kind of angle mode. Press save on the bottom and that's it, if you have a magnetometer on your GPS. If you don't have a magnetometer on your GPS, well, you need to apply a command to tell the position hold to work without a magnetometer. It's gonna behave slightly differently because you're gonna have to fly 100 meters straight for it to understand its position, and then the position hold is gonna work. Otherwise, it's a little bit messed up and the drone drifts. If you have a magnetometer, it's much better. This is the command, set position hold without magnetometer on, if you don't have a magnetometer on your drone. I'm gonna put it back to off because I have a magnetometer on my drone and I'm gonna use it. And now your drone is set up for position hold as well. There are some commands for fine-tuning how it's behaving. I'm gonna leave them in the description if you need to do that. But usually it's gonna work straight out of the box. And before flying, it's strongly recommended to add a couple of indicators on the OSD tab so you have visual feedback of how many GPS you have, the ground speed, altitude, and home position, very important. So let's set them up. First of all, this is the OSD tab and it's very easy. This is what you see in your goggles and these are the things you can activate. GPS SATs, very useful. Let's add it and put it at the top. So you know when you have 8 or more satellites you can start flying. Home direction, home distance, GPS speed, this is all stuff you will need. Your speed up here and the arrow indicating where your home point is. This is very useful if you do longer range. You can always know where the arrow is pointing and where the home is. I also strongly suggest adding latitude and longitude. Just put them in the corner. If you lose the drone, you can watch the DVR and the last latitude and longitude is more or less the area where the drone crashed. So you can go search for it if you want. And also up here is the altitude. And when you're done setting everything up, just press the save button on the corner and you can go fly. And finally, it's time to fly. If you are testing out the GPS for the first times, I really strongly suggest you going in an open field without obstacles, people, and with soft terrain like grass. So if the drone falls, it has less chances of breaking. And if you want to use the magnetometer, you must set it up correctly, especially its orientation relative to the drone. If you don't do that, the sensor readings are gonna mess up with all of the other readings you have from the GPS, gyroscope, and it's gonna conflict. So when you activate GPS rescue or position hold, you're gonna have the drone drifting, maybe circling, maybe it doesn't know where home is, and you're gonna have problems. So make sure I'm gonna leave some documentation in the description down below. It's a big topic, probably for another video. If you are not sure on what to do with the magnetometer, I suggest you toggling it off using that command I gave you before, so you can use position hold without it. If you use a M10 GPS, it's gonna work well enough that the drone stays very, very stable in the air, even without magnetometer, because it has still the accelerometer in the flight controller. I will fly a couple of times and show you the difference flying with the magnetometer turned on and off, so you can judge by yourself. Long story short, depending on your GPS module, most probably you're gonna have your magnetometer chip soldered on the bottom of it, and it's soldered upside down. So you have the magnetometer pointing downwards, and not only that, in my case I mounted the GPS at the back and the magnetometer is pointing that way, should be pointing forward. So I need to tell Betaflight that I have the magnetometer rotated 180 degrees this way and 180 degrees this way, so it's upside down. And also, since I have it as a slight angle, I also need to calibrate the pitch to be this way. I put -20, eyeballing it. And if you really want to be precise with the magnetometer, you also need to go into the CLI and input your magnetic declination degrees. It sounds difficult. Actually, check out the links in the description. You have a map, you put where you're flying, and it tells you how many degrees it's out, plus or minus degrees. Because the magnetic field of the Earth is not homogeneous, so depending where you live, it's gonna be slightly different. And once you do all of that, your magnetometer is set up correctly, and you're gonna see immediately that the home point is pointing where it should. Otherwise, you're gonna see it pointing left, right, or forward, and don't activate GPS rescue if you see that. This flight is gonna be with the magnetometer on, and you can immediately start using position hold when you have the magnetometer on. The drone is gonna come to a stop. I just press the button and it stays there. I'm not touching anything. It's incredible. And you must set your throttle stick to 0, as you are seeing, and you can still use the yaw and pitch forward, and it's gonna work just like a DJI drone. When you stop, the drone brakes. Oh my god, position hold fail. Oh my god. Yeah, it's not perfect because the barometer, when you accelerate, the air goes in, the pressure goes high, and sometimes you can lose the position hold. It's not perfect yet, but is mostly good enough. You can only activate it if you are mostly straight. If you push and activate it, the drone is gonna have a hard time balancing. You are seeing it. So be careful and only activate when you wanna park momentarily the drone, and don't trust it too much. Okay, you see I'm standing still now. Boom. And it works mostly good. And now let's check out the GPS rescue. You are flying. I'm gonna simulate with a button, but you lose signal. Boom. The drone stops, comes back, and it's working. I mean, this GPS rescue has been there for years. With every update of Betaflight, it works better. Now it can even kind of land the drone because it's gonna shut down when it hits the ground. It's not as good as a Mavic, but in case of emergency, it can be a lifesaver. And usually, I don't suggest you landing with the GPS rescue on. I only suggest you bring the drone closer. Now you should have signal back, and you can land it yourself. I don't have the throttle exactly right, so you were seeing it was jumping up and down, because this drone is very powerful, and I thought it was 26, but instead is 21, so I need to lower the throttle a little bit, but it's fine. It's still gonna come back, just not as cleanly as it could. No hands! How cool is that? I don't trust it too much, but it's super, super cool. And now let's fly with the magnetometer turned off. Remember, you also need to input this command in the CLI to tell the position hold not to expect a magnetometer. And you cannot activate it straight away. It's gonna fail. I'm gonna go a little bit higher because I can recover it. You see? Fail. It doesn't know where the drone is. It doesn't know it's heading. Because you don't have a magnetometer now, what you need to do to activate position hold is just start flying straight for like 100 meters. Don't touch anything else. No roll, no yaw. Just let it fly straight so it understands its position relative to home it's heading. And now it will work because we have set it up correctly. I'm gonna come back here on this field. Always be safe when testing things out. And boom. And I'm gonna say it works better than with a magnetometer. Maybe I've not set it up perfectly, my magnetometer, but it looks so much straighter to me. I don't know, maybe my GPS is moving on the drone, but it seems like once you fly straight, I'm just talking. You see, there is some negative feedback going on. Always, come on, always be ready to get hold of your drone. Always do your tests. If it works, that's good. If it doesn't, maybe use the magnetometer, maybe don't use the position hold yet, depending on your setup, or maybe you need to fine-tune the settings a little bit. I'm gonna try using the position hold here. Oh, you see? Okay, no, it works a little bit better with the magnetometer then. Yeah, no magnetometer is still quite fine. Maybe it's a little bit more drifty. Yeah. Now I'm gonna show you GPS rescue without the magnetometer, which is gonna be quite the same, honestly. Boom. I activated it and it does the same thing. Maybe if it's windy, the magnetometer helps with the heading a little bit better, but GPS rescue so far works very well. They have fine-tuned it very nicely. And the drone is gonna come back and land. Since I took off from the pool, I don't know if it's gonna be precise enough to not land in the water. I don't wanna destroy this drone, I like it. Let's see. I'm gonna put it in angle mode just in case. I don't trust it, it's over my head. Let me just scuttle on the side. Yeah, I don't like the way it's coming down. It's not fine-tuned it perfectly. Again, you must fine-tune it and keep practicing until you get it right. I still need to fine-tune a couple of things, but I'm already very happy with the way it's working. And I also tested it on a smaller drone with a much smaller M10 GPS. It's not working as good as this one because it also doesn't have a magnetometer. And with that one, I had a little bit of drift I fixed by calibrating the accelerometer of the flight controller on a flat surface. So if you see your drone drifting, maybe that could also be that reason as well. And that's all for today. Finally, this drone is ready to go on my backpack with the added peace of mind of having a GPS on it. And as always, remember to like, subscribe and comment on this video. Let me know what do you think about the GPS position hold, what do you think about this tutorial, and if you want me to make more of them. I will be very happy to. Also, I recommend this drone, get it with the GPS already installed, you're gonna save a lot of time, and if you wanna buy something, check out the links in the description below. Clicking on them, you help my channel a lot, and many times you also find discounts, especially for this drone. Thank you so much, stay safe, and happy flying, bye!